The clues are in the name. An unconditional testing approach is there's no conditions. You press a button, the number you see is the number you get. And as long as your equipment is accurate and you know how to use it, it's the most unconditional way of testing that equipment. The conditional approach means you need to do some maths, and you need the information to be able to do some maths and look at some graphs and understand what you're doing. There's some conditions associated with it. And a straw poll of, probably like you did, of people that do these testing, I found precisely 0 of the people that I spoke to understood how to do those calculations, right? So there's a whole bunch of people running around using this equipment thinking the number that they're seeing is the number that they're getting. Now, the advantage we have with that miscalculation, shall we say, is that the number that you read is always lower than the number that you get. So at least they're inaccurate on the right side of the line, that hopefully the systems are doing more than they're getting.
But also, that also creates a different problem, though, because if you have a fan that needs to achieve 15 litres a second and your device is showing, say, 12 litres a second, and you don't understand that you've created a back pressure and reduced the flow of that fan, you're now going to have to tell your building contractor that fan has failed to meet the requirements. That contractor now is going to rip that fan out, replace it. You may have 5 or 6 of these in a home, all of which you've just told they failed. They rip them out, they have to replace them all. But actually there was nothing wrong with them and they met the minimum requirements. So it's a double-edged sword. We must be careful of that.
Yeah, and in any testing process, the accuracy of both the device and the process that you go through is really important, because you need to understand where you sit in the world. And one of the challenges that we've had in Ireland has been getting alignment between the people that are commissioning ventilation systems and the people that are coming along and validating them, because somebody that's commissioning it might be using an unpowered flow hood and getting within the ballpark, and assuming they're seeing something that they don't. And then a validator is coming along later on in the process and not able to achieve the same numbers. And you then start, whether it's a regulatory problem or not, what it does is it creates a friction in the marketplace where people don't trust each other, where you have a misunderstanding of what you're actually seeing. And also some products out there, that, so people are aware, don't necessarily have an ability to increase ventilation in very small increments. So you may only have a choice of having 13 litres a second at a particular fan. And if you're reading 9 on it and thinking that it's not doing what it should do, you can't increase it by 2 or 3 litres a second often. That's it. So you might find yourself in a position where you're throwing something away or saying it's not doing the job when it is. But I think more fundamental than all of that, and I think you nailed it really, when we're in a position to get an accurate reading, why are we messing around with something that doesn't give us an accurate reading, or have the knowledge to get the accurate reading through those calculations? That why put yourself in that position? Field measurement comes with enough confounding factors as it is.
Yeah. I mean,
without relying on
Let's look at the rest of the construction industry. Would electricians take a guess? It's about 50 amps. No. Would window fitters, would we do this with anyone that takes accurate measurements in construction? Would you take the concrete slump rate and go, it's about that. We think it's about that. We'll be okay. You wouldn't do that in substantial other parts of the industry where it is life and death. And as much as people say or may counter, ventilation is a life, or it is my opinion. Ventilation is critical. It's a life critical part of a construction, because if you're in a very airtight home, and I'm the first person to stand up and say this, if you're in a very airtight home and you do not have adequate ventilation, you are very, very quickly and very likely going to have problems. And that may be mold, that may be humidity, that could be building sickness of a ton of varieties. And, it goes right back to my original point. If you're going to build an airtight home, you have to ventilate it correctly.